Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Hi there. So for this problem, we need to calculate the first the electric potential at corner A, and to do that, we just simply need to use the equation for the electric potential. In this case, it is the product of the Coulomb's constant times the charge over the distance to the point we want to obtain this quantity. So in this case, if we put ourselves in this point A, we will see two charges. One that is at 0.0 meters, meters or 5 centimeters, and the other negative charge at 0.15 meters or 15 centimeters. So with this equation, we can just use the superposition to sum all of these contributions. So in this case, we will have that at position 8, we will have constant Q1, the distance R1 plus constant the charge 2 over the distance R2. So we are going to call this is Q2. So this in here is R2 for this case. In this case is R1. So what we need to do is just simply substitute all these values. We can see that we can factorize the value, the Coulomb's constant, and we know that the Coulomb constant is 9 times 10 to the 9th, and the rest of it is Q1. Q1, yes, the charge 1 has a value of minus 5 microcoulombs. Microcoulombs means times 10 to the minus 6. So we will have minus 5 times 10 to the minus 6 coulomb over the distance to the from the point A to the charge Q1, which is 0.50 plus that product of the second charge, and that is it's the value of the charge over the distance to, we're gonna leave the, and the distance which is 0.05. So putting all these values into the calculator, we obtain a value of 6 times 10 to the 4 volts. So this is the electric potential at point A. For part B of this problem, we are asked something similar, that at point B. At this point, we can see that the charges are the same, but now we are 0.15 meters from the charge Q2 and 0.05 meters from charge Q1. So we need to change those distances. So we use the same equation, but changing those values of the distance, you know. So we will have this. And in this case, we're putting it here. R1 is the distance to the Q1 is 0.05 meters, and for R2 we have this R2 and we have 0.15 meters. So Once we have this, and the other are just the same as before, 9 times 10 to the 9 for the columns constant, and the charges are the same. 6 over R1, that's the one that changed in this case, plus Q2, which is 2 times 10 to the minus 6 over 0.15 meters. So when we put all these values into the calculator, we obtain minus 7.8 times 10 to the 5 volts. So this is the electric potential, yes, in the point B of this rectangle. Now, for part C of this problem, we are asked to determine how much work is required to move a charge Q3, which has a value of 3 microcoulombs, which is 3 times 10 to the minus 6 coulombs, and from B to A along the diagonal of the rectangle. So we want to do this. We want to move charge Q3 from B to A in this direction. So to this, we are going to use the fact that the work done by, so putting this in black, the work done for a system is the change in potential energy. So in this case, we will have the final potential energy in minus the initial potential energy. So the potential energy in electrodynamics is defined as the charge, or the charge times the potential and the electric potential. So in this case, it will be Q3, which is the charge that we are trying to move, times the final potential is at A because we are moving it from B to A. So the final position is at A, so we put the final potential minus Q3, the potential at point B because it is the initial one. So we just simply need to substitute all these values. We can see in here that we can just factorize Q3. So we will have Q3 has a value of 3 times 10 to the minus 6 coulomb, and it will be 6 times 10 to the 4 volts minus because we obtained that for point B is negative, so it is minus 7.8 times 10 to the 5 volts. So putting this into the calculator, we obtain a value of 2.5 joules. So this is the work done by moving a charge Q3 from point A to B in this rectangular system or configuration of charges. The final question for this problem is, does the work that we just already obtained increase or decrease the electric potential energy? And the answer it is that it increased the electric potential energy. Increase the electric potential energy. This is because we have obtained a positive value, so that in this sense, since we have obtained a positive value, we will increase the electric potential of the system, and that will now be of three charges. So this is it for this problem. Thank you.